Okay, we'll now move on to our second presentation for today, which is brought to you by Kieran on the topic of IAC and analytics on GCP with stackql. Kieran has racked up a decade in IT professional services after a previous career in research science. He is also the co-founder of CTO stackql. In this session, Kieran will present a case study in managing a GCP cloud estate with stackql, including a brief and open rundown on how stackql works and how to run IAC and analytics on top of it. Can I please get a round of applause for Kieran, please?
Hi everyone. Is my microphone? Yeah, it's working. Okay, cool. Let me plug this in. Okay. Are we good? Okay. All right, I'll just start talking beauty. So first, well, that previous talk was super impressive, and the movie was just killer, so that was good. Big shoes to fill. So I am going to give you a very sort of unscripted, not slick sort of a prezzo here. Just talk a bit about stackql, our product, and what it is and what it does. But I'm going to work backwards from what we can do on GCP with it. And then I'll go down to the nuts and bolts of how it works. And I think the ending time should be about 20 past, so I'll make sure I don't sneak over, because I'll just do demo apart from that. So yeah, thanks for having me, everybody. Very deeply grateful for this privilege. So stackql. What is it? Who are we? Basically, in COVID, we were really bored, and we were. I'm not going to sort of dump on any tooling. We're really, but we were a bit tired of some of the tooling we were using, and we thought, hey, maybe we could sort of drive some of our hyperscaler infra with SQL sort of grammar. And so there's other stuff in the market that would do that, and other startups that do similar, but we thought we'd do it a little different. And we started with Google. And in fact, Google gave us the inspiration with the sort of model of provider service resource for all of the different offerings for what we would then do. So I'm just going to jump into straight about talking about how you can do infrastructure as code workloads, and in particular on Google. So this, I'm trying to keep, because of our wonderful host, I'm going to keep everything very Google-centric, but there's no need to be, right? But we want to be, because we're really grateful that you're having us. So basically, inspired from the Kelsey Hightower's Kubernetes the Hard Way, what we can do is I can jump straight into a demo, because it's much better than me talking through it. I've got some slides in case this demo would break. So first thing, I need to find the right one. So we've developed a tool called which works on top of the core, and remember I said we'll walk backwards from the glossy slick stuff down to the nuts and bolts. And so the tool that we've developed is called stackql deploy, and it just enables us to wrap a bunch of these SQL type queries in a convenience library, where it's just a config-driven Python library. I'll drop you guys a link. There's a link in the slides to it. But we can, through a series of commands, not dissimilar to some of the other IAC tools, we can build, test, and then tear down infrastructure. So let's just have a look at what I can do with a test. So I've already run one of these things, because they take several minutes to run. Yeah. Oh yes, wait, sorry. Yep, let me do that. I'll do this. Zoom in. How do I zoom? Let's just try this. Yeah. Cool. Oh, the actual text here isn't super important. So I'm just going to run a test. So basically, this is just going to validate that all of the infrastructure in my config files. I can show you those. Let me show you those. I've got all these. Oops. Now let's do this. Now let's go here. I've got so many things open. Okay. I've got these. Wouldn't worry too much, but I've got these YAML files full of configuration telling the application how I want to deploy all of my infra. It's just environment type stuff, so I can have different deployment configurations for different environments, dev, sit, prod, whatever you might want to call it. And it's going to run a series of steps, kind of like a big fat transaction where we're going to go through and expand these templated values and then deploy and check the infra. So as I said, there's one that I already cooked before. Let's just have a quick look. Sorry, I know I'm flashing around here, but let's just have a quick look in the ClickOps zone. And I've got all these VMs. These are all my Kubernetes, the hardware VMs, deployed using this script. So first thing, let's just run a check and see if all this is exactly how I expect it to be. So this is just going to go through, do all that template expansion, check that everything is how it should be. Okay? Away we go. Perfect. It's coming. It'll take a little while. So while that's happening, I was just going to show you one example which hopefully shows some of what this can do. By no means all. I'm just going to do something nasty. Go over here and just ClickOps delete one of these guys. So I need to stop it first, I guess. Okay, I'll stop it. Okay, it's going to stop. We'll just wait. Now, hopefully oh, it's still going, still testing all these things. Yeah, cool. So all those tests did pass, right? Obviously, it tested the machines before I did my bit of ClickOps. So that one is stopping. Can I now delete you? I'll try and delete it. We'll just let that one delete. It'll go ahead and delete. Okay. Come on. So, while that's happening, yeah, so that's going to delete. I'm going to come back through and then just rerun my whole build process, and it will detect that one of these things has been deleted and we'll recreate it. And so then we'll jump to another thing. So 1 second. Let's give that a shot. Let's run the test again. Let's run the build. I'll get rid of your debug logs. We don't need to see all of those. Still going. Come on. Take a while to delete a virtual machine. All right, good. It's deleted. Okay, sweet. So now I'm going to rerun my build script. It's going to go through, and if the gods are with me, like I did before, it's just going to recreate one of those machines for us. And so there's a whole bunch of other stuff in there. Let's just go and do it. Let's kick it. Away it'll go. It'll take some time. In the background, kind of what it's doing is it's just running a sequence of stackql commands, which I'll get to in a bit, to first check what's there, and then if it's not what's expected given the configuration that's input, then create it, and then verify that it's created and in some cases running the way it's expected to be. It's configurable in terms of in some of those behaviours in terms of like how many retries would happen and that. And one of the reasons I'm not doing the full demo for you is, earlier on the way I had it configured, a lot of the retries were failing, so I just run it multiple times and eventually it gets deployed. It's pretty easy. So while that's happening, yeah, there's all manner of other stuff that's managed in this same way. Let me just get rid of this. Okay, yeah, there's heaps of different disks. There's one disk that I ClickOps down here. I'm going to talk to you about that disk a little bit later. We'll come back, but all the other stuff was created using stackql. It doesn't have a state file. It can just recapitulate what it expects to be present based on your input parameters. It's going to then go and quiz the project, quiz the container, whatever it might be, verify that that's there, and then react accordingly. So that's going to go away and do that stuff. We'll just come back. I'm going to jump back to the infrastructure as code side of it. This is a little bit schizophrenic, but it just enabled me to get through a bit more stuff. Okay, so as well as infrastructure as code, there's a bit more to stackql than just running infrastructure as code deployment. So we can do analytics, and ultimately to empower some of that IAC stuff, what we're looking and other workloads too, hybrid workloads, is we're looking to support pretty decent transactional semantics inside stackql, which is a pretty big undertaking because it's kind of like turning the internet into your database. And anything that we can access over web service and potentially, TCP/IP, once we figure out how. So yeah, we're just demonstrating that we can in fact do mutations. We have simplistic support for rollback action. So where where we understand some resource well enough that we can reverse some process like an object creation or whatever, we can do a rollback. It's sort of very much best effort stuff at the minute. We do have support for isolation. We're pushing it uphill a little bit. Like it's quite a complex problem to solve. Like I've tried to get my head around all this stuff like Aries and whatnot, and I don't know how to do it, across all of the internet. But it's something where we're interested to do at least at some level to have some support for transactions, because it would make stuff like management of complex cloud estates quite powerful in conjunction with tooling like that stackql deploy, which I'm just now showing. So that's a good segue. Let's just see how that is going. How's it finished? Yeah, sweet. So that's finished, right? And so then hopefully this hasn't self-refreshed. If I come back here, how many have we got? 1, 2, 3, 4, 5. Hopefully if I press refresh now, we're going to have 6 virtual machines again. Please. Yeah, beauty. So there you go. It's just gone and done that. Wasn't too hard. I don't have to worry about a state file or storing it somewhere and then keeping it encrypted with customer supplied encryption keys and all that sort of stuff. So that's nice. And that's just something, actually, I'm the CTO and there's really 2 of us co-founders who've done the bulk of the implementation and ideation on all this stuff. And there's a lot of copying from open source, obviously, but I actually haven't written a line of code on this stackql deploy. My co-founder Jeff just told me, hey, run through this demo, and away she goes. So I'm doing more so the core stuff. Jeff's doing a lot of this tooling on top. So he's just done this in very few weeks from idea to reality. So that's something I wanted to show you guys. So we can do IAC. Now, we can do analytics. I won't go through the glossy stuff too much because in all honesty, it's not very glossy. But I do have this one dashboard here. This is just stackql. Sorry, this is just a superset dashboard running on Kubernetes, supported by stackql in the background. And this one, I'll just be really honest. I'm trying to be, covers off honesty sort of thing. So this is one dashboard where all of the views are materialized. So this data is not current. You can do it with I can do it with current data and live refresh and whatever. But if I do, I think where is it? If I do the there's some refresh button. I can't remember how to do it. Yeah, force refresh. I can do a force refresh, but it's just going to hit the same. It's just going to hit the same object. It's not. This one's not actually going to the provider. You can do it so that it does, but it's just riskier when you're demoing to people. So you can trick it out and do all sorts of stuff. So now the part that I like is how do we do all that sort of stuff. So before I go into that, so two real lines to this, I guess, in terms of usefulness. One is IAC, the other is analytics, right? There's the stuff that you can do with analytics. I'm not really a business person at heart, so a lot of it slips past me, but there's things like cloud security, posture management, FinOps, things like that. Trying to work up use cases on that, but because there's only 2 of us, it's sort of like, and we both have day jobs that are quite demanding. It's very much a case of burning the midnight oil, spending all of your weekend doing this stuff, and we've got children and hobbies and all this. So yeah, the sharpening up of the business cases is a bit of a work in progress. So I'm just going to get rid of that now and just go back to my slides for 1 second because there's something I do want to give you the sales pitch now. So this is the sales pitch. I'm going to leave this up here for a second. I'll come back to it at the end as well if I'm allowed. We really, really want GitHub stars on our main repository, which is stackql. So please go to stackql and give us a GitHub star. We'll do anything. So then just get my mind back on the job. So enough of the deployment stuff. I'm going to go here. So is it this one? Okay. So So now, the core product itself, it's sort of like it's basically just a SQL. It's something where it's a tool where you input SQL and you get out stuff from the cloud or whatever you're pointing it at. It can be on your local machine as well. We haven't really expanded fully where to go with that, but I'll just go through a really quick sort of contrived talk on what I can do with this. So if I run in shell mode, I know I need to pump this up, don't I? Let's go bigger. Oh, here we go. Cool. That should hopefully be big enough. Well, let's make it a bit bigger. So inspired by Google, and this is not a word of a lie, the discovery documents that Google publishes seem to go from the Google provider to different services like compute, to different resources like VM instance or network instance or whatever it might be, and all the other services that Google offer, and then finally resource. And so we thought, hey, that's quite similar to like this sort of database table, schema type of resource, which SQL databases, which RDBMSs have. So let me just, what's happening there? What is going on? It's too big, I think. Oh, okay, all right, it's down the bottom. Let's get it up there. Okay, come on. Now what's going on there? Why down the bottom? We're going to do this. Okay. Okay, so I'm in. We have like basically a REPL shell where it's where you can just run it in one integrated process. We do other stuff as well, which I'll get to. Oh, whoops, because I typed something earlier, didn't I? Show providers. There we are. So we have some meta commands where we can interrogate our hierarchy. So I've only got 3 because I like Google so much and I don't like the competition. I've just got Google and a couple other things which I don't think are direct competition sitting here. And so I can say, okay, so let's look at the Google provider and what's there. So I can say show services. Okay, let's show them, and there's a lot, right? It's flashed past your eyes too quick to even detect, but I can sort of filter it as well. Okay, so I've got these, and then I can do the same. So if I say show, I want to look at the resources. Google Compute. Show resources in Google Compute. Let's look at the disks, right? Remember I had that contrived, let's do this. Hopefully it will work. Bang. Okay, that took a little while, but I have these, I have Google Compute disks. I can even go one more. Now, because we, like relational databases, the data is just stored on disk mostly, or maybe a whole collection of disks, and I've still got a while. But on the internet, it isn't, and mostly, we're not going to be always excluded to this, but mostly we're just talking to web services. And for Google, it is web services, so there's all sorts of stuff like required parameters and authentication and things that you don't have to do against your local hard disk. And we try to abstract that, and when we're doing our analytics, we can sort of do hidden ELT so that you're just talking to Postgres tables and things like that, or Postgres views, but in the core product, we're talking to web services. So there's another layer, right, that is less glamorous, but I can look at that. I can look at the actual HTTP methods that are down there. Okay, look at these guys. And it's got this nice one, it's got this nice one called aggregated list. This is one that's present on, all the hyperscalers seem to sort of namespace things one way or another. Obviously Google does by project. Then there's some resources, where I can only quiz by, region or by zone or whatever. And some of the more popular ones, I guess, they've aggregated up to project level, so I can aggregate all the different regions that are present. So if I want to look at all of my disks, I can also do a describe. What does I call it? Google Compute disks. Okay, whoops. I can describe that. So there's lots of stuff. I can't filter this one, but there's lots of different fields. So I can see what the basic schema looks like. We haven't made this fully. It's never going to be RDBMS identical or have parity, because some of the endpoints, like there's there's response-only type of attributes. They only come back. They're created dynamically or whatever, so they don't. The stuff between like an insert into and a select, there's always a difference, and there's differences when you do a get or pick a particular object versus a list a whole bunch of objects. But we by and large we get away with this, right? To be totally honest with you. So if I want to do a select, I'll just do a select. So let's just go to my demo project. Demo. So I'll just select a couple of interesting things, and and then we'll get to me using the up arrow because I can't remember all the stuff I was wanting to show, and it's too hard to type it all. So I'll just say select name. Oh, whoops, that's not going to work because case sensitivity is in place. So it'll work for select, but not for the name. Select name, ID, region. I think we've got region here, do we? Yeah, we've got region, we've got zone. Okay, so have I got any more of it? Yeah, sweet. So that's pretty yuck, right? So I mean, even if I made it smaller, it's pretty yuck because a lot of this stuff comes back as these sort of URLs, which are quite long. So the region and zone, as it turns out, both do. I've got my ClickOps, my nasty ClickOps disk up here. That's a regional disk. All the others are just in a zone. So I can make this a little bit prettier, and let's get to our up arrow. All right. I'm going to show you a bunch of stuff. So hopefully, 7:16. I'll finish up quick. I've got one. I'll wrap it all up in one. That's it. Okay. Oh, that's wrong. Okay, so I can write a view of I can do a couple of things. So I can use case statements to pretty up, and I can use some of the bog standard SQL functions. We use if I get time to talk about what the SQL backends are, I will. Otherwise, just some greatest hits ones. So we've got split part for dealing with URLs that have got lots of slashes in them, and we've got some JSON parsing functions and whatnot, which are obviously quite convenient when you have deeply nested data that you're interested in. So we can do all that. So I've created a view. So the data fetch is lazy on views, like it sort of makes sense, So if I do a materialized view, it's going to go and fetch the data eager. And so that was quick, right? That bounced back really quick, but it'll be a bit slower to select. So let's just do a select star. Okay. There you go. So it's actually gone and fetched that. It probably happened pretty quickly that time because the network's so good here and whatnot. I can do other stuff. I think I'm probably running out of time to demo the other stuff, so I'll stop demoing and just give you the quick spiel on how this actually works. We can do other stuff. We've got materialized views. You can create tables in your own user space. So if you want to do, some kind of star schema or whatever it might be, you can do that. I was going to demo that, but there just ain't time. So we have, okay, sweet, let me just do this. Let me just do this, I'll just talk to it. So you can install this application from, it comes with some of the package managers. Haven't done like any of the Linux ones yet, I should do. We have a download, we've got a website where we put our latest release. There's a Docker version, done all that. You can actually run it as a server. I think I'll probably be out of time, so I won't demo that, but you can just run it as a server, a Postgres server, and talk to it using pSQL or pretty much any client. That's how we do the dashboards. We're sort of talking to stackql over Postgres wire protocol. We aim to not be too opinionated about how people ought to use it. We just want to, ultimately, what I want for this is for it to just look and act exactly like an RDBMS. So you can just talk to the internet like it is just a relational database is the basic idea, and do whatever you want with it. If you want to do deployments, it's just insert into. If you want to do analytics, it's just select from and creating views and all this sort of stuff. So cool. I'll just So really quickly, all written. The whole core is written in Golang. Most of the most of the dependency libraries, we've got a couple of big dependency, well, very important, not large, but quite important dependency libraries that enable us to understand how to talk to hyperscalers and all these other different SaaS and cloud providers that we do. Basically, it's driven from Swagger or Open API documents with extra bits of legal Swagger markup added so that stackql can understand how to do things like reverse actions or whatever it might be, or special bits of response handling that we want to do to make the experience a bit better for the user. We ripped off the core of the product from a open source. I think it's a MySQL sharding system called Vitesse, where they have like a SQL parser written with Go. So we've sort of ripped that off and then adapted it to this case. So that's our main repo. We have this one. Do I still call it this? No. So this one we've renamed as NESDK. So I've got this other one. We have the parser. This is the Vitesse I was talking about. These are all very, very important. The thing wouldn't work without them. This one, it's just an open source Postgres wire protocol implementation in Golang. We've forked that. As I said, we just want it to look. It's nothing to do with DuckDB. We just want it to look and quack like a duck, and you can just talk to it like it is a Postgres. And in fact, that's exactly what the analytics thing is, because we just sort of run stackql with Postgres as a backend, and then kind of detach it at will, and then away you go with your analytics. There's other ways of doing it too, but that's the basic premise. Sweet. There's other stuff. I think that's enough from me, basically. There's a lot of other history that we've got. There's a lot of other stuff that we want to do. But I think those are the main things I wanted to highlight. You can use it on Google now for analytics and for IAC. And thank you very much, everyone, for having me.
Thank you so much, Kieran. Do we have any questions for Kieran this time? Yeah. Again, we'll take 3 questions.
Thanks for presenting that. Love infrastructure as code stuff. Is there anything that the Google Cloud provider doesn't do for those of us that want to dive right in, or is it fairly mature at this stage?
I won't lie to you. You'll find defects and bugs, because what we've done is we have like some JavaScript and Python code that just takes the Google Discovery docs and turns them into our Swagger Plus markup. And so we've made mistakes and we haven't caught all of them. But yeah, we'd love you to use it, and then you can send me vitriolic emails. My email's on this slide somewhere. I'll put it out the front. So please feel free to hit me up with some absolute vitriol. There I am down the bottom. Yeah. Please, yeah. If it's broken, just hammer us.
I'll try and find some. Thanks. I won't send you vitriolic emails, but keen to give it a shot. Thank you.
Thank you.
Do we have any more questions for Kieran? Any up the back?
Hi, thank you for the presentation. It was really nice. I guess my question for this, especially looking at, the IAC part, so like looking at sort of competitors, like Terraform and the native tooling and like all the other, all the hyperscale platforms. I was wondering, how are the struggles with integration? Like you mentioned how you have to go through all these additional processes to basically facilitate the ability to access all these resources. I guess from your end, do you see that there needs to be maybe more collaboration with all these other hyperscalers, proactively to get those support, or is there anything you feel on your side you can do a bit more?
Oh yeah, look, well, we've had some discussions with some technical guys from a couple of the big ones, including yourselves. I won't name any names, but they've been generally pretty supportive, and also asked if there was anything that would help us to uplift, to the previous question, to get the provided service resource documents a bit more error-free so that people can start using. And look, with Google, it's less of an issue, but some of the other major vendors, I wouldn't name any names, but still have loads of like really old school stuff kicking around. So that's difficult. And there's lots of, we're not machine learning experts and whatnot, but that's what I'm hoping machine learning can sort of solve for us, how to turn a 20-year-old XML endpoint into something like a relational database table. But yeah, there's been a bit of manual work to make that happen, and it's a work in progress.
Awesome. Thank you so much.
We can probably take one or two more. Does anyone else have any more questions?
So you said that you are one of the co-founder and two people basically made this whole system. So how long did it take you to do this on weekend with handling all your jobs and your family and kids?
So we got from nothing to being able to run probably, select queries on Google in about 3 months, I think. And then we had a complete teardown and rewrite where we moved away from directly hitting your Google Discovery docs to using Swagger Open API instead. And so it's probably been looking at highly similar, plus or minus less errors and more resources for about the last 2 years. So I guess that means from it was like late, what was COVID? So it was early 2020. Probably took us 2 years to get it looking like it looks now with a Postgres interface and a REPL shell and all that. But it was way worse 2 years ago. But we've just been iterating on this structure for them. So 2 years to get there. Yeah.
All right, thank you.
I think
one more question from here.
Yeah, it's a rather more simple question. So is this more of a configuration management tool or more of an analytics and querying tool? Because we've got Terraform on one hand where you can, to a very detailed level, you can specify the configuration of on an instance level. But going through the documentation of stackql, I feel like there's still that part left.
Yeah. So in terms of like doing IAC as bulletproof as, to name a competitor, Terraform, we're not quite there yet. Because what we're doing is, for IAC, what we're doing is really a thin layer over the APIs, if you like. To get a little bit technical, like Terraform and the like, just use SDKs. We're using HTTP endpoints, so we can expose all the same stuff. Whether we can make it as easy to use and as consumable, that's an open question. We haven't delivered that yet. We want to. For analytics, I think we're a pretty good natural fit because it's just queries, and we're going to support all that. We do support materializations and views and all that for all the nasty stuff, like where the data is coming back deeply nested or in some bizarre form. So I think that's a lot of hot air, but the sooner goal is the analytics. We can do that quite quickly, and then we want to deliver on the IAC. And I want proper transactions, but that's probably going to take a long time. Yeah.
Thank you.
Right.
Thank you so much. We also do have a presenter gift for you too.
Thank you, Colin. Oh. Thanks, mate.
Thank you.